So in our previous lesson, we had discussed how to take the derivative of all of the trigonometric functions using the limit definition of the derivative. The focus of today's lesson will be a shortcut that we haven't learned up until now, which will essentially make taking derivatives of power functions much easier than it used to be. Rather than using the limit definition where we have to plug in the x plus h, subtract off the f of x, and then divide everything by h, that can get very time consuming and waste a lot of time on a test. So we will be learning a shortcut called the power rule in today's video. So if we wanted to take the derivative of a function of the form d by dx of the function a times x to the n, where it is that a could be any kind of constant, so say that this would be a function such as 4x squared. Our a would be 4, x would be x, and 2 would be n. So if we wanted to take the derivative of any power function, essentially what it is that we would be doing is we would drag the power down and then subtract 1 from the exponent. So what we would be left with would be n multiplied by a times x to the power of n minus 1. See how that works? You just drag the exponent down, multiply it by the constant if there happens to be one, and then subtract 1 from the current exponent. So using the power rule, we want to evaluate the derivative of the function 4x to the 6th power. So d by dx of 4x to the 6th. Well, essentially what it is that we'll be doing is we'll take the exponent, which is 6, and drag it in front of the coefficient which is already there. So we'll have 6 multiplied by 4x, and then we will subtract 1 from the current exponent. Since the current exponent is 6, we will make this a 5. So what we'll be left with is 6 multiplied by 4x to the 5th, which will be 24x to the 5th. And if we wanted to use the limit definition of the derivative, everything would check out. Last example for power rule, this is very simple. We want to take the derivative d by dx of the function 7x to the 3rd. As we did before, we drag the exponent down, so we'll be left with 3 multiplied by 7x, and then we will subtract 1 from the current exponent, which is 3, so that will become 2. So we will be left with 3 multiplied by 7x squared, which is 21x squared. That is the derivative of our function. So now very quickly, let's introduce a couple of rules that are quite analogous to the limit laws that we had already discussed in the previous limit videos, which are rules that are made for taking derivatives. They are pretty much exactly the same as the limit laws that we have learned up until now. We have the sum law, the difference law, and all of those other laws. They're slightly modified for the product and quotient rule, but we're not there yet. So the sum rule basically says that the derivative of a sum is going to be the sum of the derivatives. If we wanted to write this down in formula speak, it would be denoted as d by dx of f of x plus g of x would be d by dx of f of x plus d by dx of g of x. Essentially what it's saying is the derivative of the sum is the sum of the derivatives. If you wanted to take the derivative of a sum, a really long chain of additions, then all you need to do is add up their individual derivatives, much like whenever it is that you're taking the limit of a function as x approaches a certain value, you just add up all of the limits, and that's the limit of the entire function. And much like the sum rule, there's also a difference rule, which is pretty much exactly the same as the sum rule, but instead of additions, it's the same concept but with subtractions. So, difference rule says that the derivative of the difference is the derivative of the difference is the difference of the derivatives. If If you wanted to write this out in formula speak, it would be very similar to the sum rule, which would be d by dx of f of x minus g of x would simply be the difference of the derivatives. So this would be d by dx of f of x minus d by dx of g of x. And one last thing that you should probably know before it is that you start taking derivatives of long chains of additions and subtractions is that the derivative of any constant, no matter what that constant may be, whether it's 1, whether it's 100, whether it's 1,000, pi, e, no matter what the number is, if it's a constant, then the derivative of that constant will always be 0. So let's write that down at the top before it is that we take a quick example. d by dx of any constant, say constant c, is equal to 0. With all of this information, let's take the derivative of a chain of additions and subtractions. If we wanted to take the derivative of the function d by dx of x to the 4th plus 3x plus 1, essentially what it would be is d by dx of x to the 4th plus d by dx of 3x plus d by dx of 1. Let's just put brackets around all of these. And then we would take all of these derivatives separately using the power rule that we had just learned. So if we wanted to take the derivative of x to the 4th, we would drag the exponent down. So this would become 4 multiplied by x to the n minus 1, which will be 4 minus 1, so 3, plus the derivative of 3x, where 3x has an exponent of 1. 3x can be viewed as 3x to the first power. So essentially what you'll be doing is dragging the 1 out in front. So this will become 1 multiplied by 3x to the 0. And 3x to the 0 is just going to be 3, because the x term will become 1. So all we'll be left with is 3. So the derivative of 3x will simply be 3. You can also just remember that whenever a constant is multiplied by x, that the derivative of that is simply going to be the constant. And then we have the derivative of 1, which we know that the derivative of any constant will be 0. So this goes straight to 0. So the derivative of our full function will be 4x to the 3rd plus 3. Now that is a lot quicker and simpler than taking derivatives using the limit definition. So I got a little bit cut off over there. Let's take the derivative of the function 4x to the 5th minus 8x squared plus 7x. Plus 7x? Yeah, plus 7x plus 4. So what we'll be doing is splitting this up into several derivatives as we have for the previous example, where we'll take the derivative of 4x to the 5th, subtract the derivative of 8x squared, add the derivative of 7x, and then add the derivative of 4. So we want to split it up into several. Essentially what we'll be doing is take the exponent, drag it down, so this will become 5. 5 multiplied by 4x, and then we subtract 1 from the current exponent, which will be 4. Then we subtract, and then we drag the exponent down as we did before, so this will become 2 multiplied by 8x, and then we subtract 1 from the exponent, so we'll be left with 1. And then we have the derivative of 7x will simply be 7, because this will be 7x to the 0 plus 1 multiplied by 7x to the 0. And then the derivative of any constant, including 4, will go straight to 0. So plus 0. Let's clean this up a little bit. If we wanted to simplify this, this would become 20x to the 4th minus 16x, and then plus 7. X to the 0 simply becomes 1, So all we'll be left with is 1 multiplied by 7. So the derivative of the function is 20x to the fourth minus 16x plus 7. And then final example before it is that we wrap up. The longest chain so far. I think we got 5 terms over here.
Yep.
Say we wanted to take the derivative d by dx of the function 6x to the 6th power minus 2x to the 4th plus 4x to the 4th plus 4x to the 3rd, rather, plus x, and then minus 5. So we'll split this up into several derivatives as we did for the previous example. So what we'll do is take the derivative of 6x to the 6th first. So we'll drag the exponent down. 6 multiplied by x to 6 multiplied by 6x to the power of n minus 1. Since our n is 6, our n minus 1 will be 5. So 6 multiplied by 6x to the 5th power. Here we drag the exponent down. So we'll be left with 4 multiplied by 2x to the n minus 1, which, because n is 4, n minus 1 will be 3. So then we add, then we subtract, we bring down the exponent. 3 multiplied by 4x to the n minus 1. n is 3, so n minus 1 is 2. And then x is exactly the same thing as 1x. And because we know that the constant of x multiplied by any, because we know that the derivative of any constant multiplied by x is simply the constant itself, the derivative of x is just 1. And well, if we wanted, wait, this would be a subtraction sign. And then finally we want to subtract off the derivative of 5, which would simply be 0 because the derivative of any constant is 0. So if we wanted to clean this up, we would simply make all of the multiplications that need to be done. So this would become 36x to the 5th minus 8x to the 3rd plus 12x squared plus 1. And that is the derivative of our original function without using the limit definition. And this saves us a lot of time. And with all of that being said, I will see you guys in the next video. I think we'll be covering product rule and quotient rule. Not too sure yet. I'll let you know when it comes out.